Okay, welcome back. Today we're going to look at naming ionic compounds, which is also called the stock naming system. So I refer to this as ionic naming or stock naming. The plan for naming ionic compounds is to first identify when you need to use this stock or ionic naming system. And there's two basic ways to do that. When you see a formula, we're going to see hydrogen at the front. If hydrogen's at the front, it's not ionic, it's going to be an acid. So we're making sure we don't see hydrogen. So either your choices are 3 or more atoms inside the formula, or you're going to see a metal at the front. If it's 3 or more atoms, it's called a ternary ionic compound, and it contains a polyatomic ion, or at least one polyatomic ion. Sometimes it could be 2 polyatomic ions. Or if it's just 2 atoms, it's going to be a metal on the front of the formula stuck to a nonmetal. That's called a binary, bi for 2. Now, this is we're taking some liberties here for our class. This is how the formulas will be written in our class, but of course there are other formulas out there that would break these rules, such as like glucose C6H12O6 wouldn't be ternary ionic even though it has 3 or more atoms inside that formula. So here's our general rule. We're going to split the formula after the cation, so you need to be able to ID the cation inside that formula. And then after we've split it, we're just going to name both ions, whatever those names happen to be. So we have some other tips on how to go about doing that. So a more specific set of rules would be this. Split after the cation, and you're going to do that by first finding the metal, or if you happen to have NH4, the ammonium cation, you would split after that. And then sometimes we have to look for Roman numerals. So if you happen to have a metal that lives in the transition metals or is a metal further right of the transition metals, check for Roman numerals. Remember that all the metals that we've talked about in class that live in the transition metals have Roman numerals, except for aluminum, zinc, and silver. Those 3 don't. Then also like tin and lead. So those would be ones that we would use. And you check on the back of your periodic table also would help you. If you see Roman numerals behind the name on the periodic table, you're going to need to include Roman numerals in the name of that compound. And then like we were saying before, just combine the names of both ions. Anions are going to get the IDE if they're just a nonmetal. Otherwise, if it's a polyatomic anion, just name it whatever the polyatomic anion's name is. Here's a flow chart of how that looks in a more of a pictorial version. So we know that we have an ionic compound because there's either 3 or more atoms in the formula, as long as it doesn't begin with hydrogen, or it's a metal to a nonmetal. The 3 or more atoms is easier to see, so then look for that first, and then if there's not 3 or more atoms, then look and see is my first atom living left of the stair-step line. Then you need to ID if your metal happens to be a group 1 or group 2, because those won't have Roman numerals, or if it happens to be the NH4 cation, that's ammonium. Just use whatever name that happens to be. If the metal lives in the transition metals or further right, make sure to check for Roman numerals on the back of your periodic table, and then use your anion to determine the Roman numeral. You would figure out how much total negative charge, and don't forget that the positive charge has to cancel that. The anion is going to take the nonmetal root, so if it's chlorine, it turns to chloride. If it's sulfur, it turns to sulfide, or whatever the polyatomic ion name happens to be. I have a picture right here of a button. You can click that button to go to some example problems for some ionic naming. Hope that helps.